So we
All
can start
right.
now, sir.
Huh?
You can
Can you
start.
can you see the slides now?
Yes, sir. Yes, sir.
Call Nelly. Let
Uh,
me see whether it is going advancing or not. Is it advancing now?
yeah. Uh,
Yes, sir. Yes, sir.
Picture. Okay, good. All right. Again, welcome back. So the ground anchor and the soil nailing is almost a similar type, a little bit of difference. Construction method is a little bit different. And then also there are different types of soil nailing methods are there. And then finally what you do, basically the soil nail, and then on the front face of any stabilized wall, so you put some shotcrete, basically, and the wire mesh, and then put a cement and that shotcrete concrete, basically, generally for the facing wall. The soil nail is a technology first used in France for the soft rock. And so again, the project is undertaken in 1961. And basically the first is steel nails are used. And also the first soil nail, also the modern soil nailing, also near Versailles also in France. So basically include high density grouted soil nail with 60 feet long for this, and facing wall reinforced concrete. So this is the history of that. So this is how it looks like after this nailing is done, and then just put a wire mesh, and then put a shotcrete, basically. So how it looks like, so reinforced shotcrete and facing wall. So basically this is the soil nail, and there's a spacing between the soil nail and the drainage layer, and how it looks like for soil nail system, wall system. This is how it looks like also. This in the top, you can see the soil nail and this anchor plate, and then nut and bolt on the top. The soil nailing is a procedure of reinforcing, basically or strengthening the ground adjacent to the excavation by installing closely placed steel bar or nails. Okay, and as construction proceeds from top down. So this is a little bit different, as I mentioned. So this is from top to down, and it is effective and economical method of constructing retaining wall for excavation support of the cart hill, bridge abutment, and highways. And this process is effectively in cohesive soil, broken rock, shale, and fixed. So this process, whatever soil is suitable. Soil nail applications, as I mentioned, the stabilized or railroad or highway cut slopes, tunnel portal of steep or unstable stratified slopes, stabilizing steep cutting development space, existing over steep embankments, you can use that. Soil nailing through existing concrete or masonry structures of failing retaining wall or bridge abutment to provide long-term stability. So it can be used for temporary, it can be used for permanent. So depending on the situation, different application of the soil nail. Suitability, soil nailing, steep to hard, fine-grained soil. If it's a soft soil, it's not good. Dense to very dense granular soil with some apparent cohesion, weathered rock with no weak plains, glacial soils, and ground that can support or unsupported or vertical cut of 1:2 meter on 1 or 2 days. So you just cut the slope, and if it is collapsed, then it is not good. So unfavorable conditions when the soil is dry, poorly graded, cohesionless soils, that is the good option. Soil with high groundwater table, also not good options. Soil with large boulder and cobble, so it is difficult to insert the steel rod or nails. Soft to very soft fine-grained soil is not possible. Organic soil is not possible. Highly weathered, highly corrosive soil, because the steel is going to corrode, or high groundwater table is there, so it's not possible. So these are the few situations where the soil condition, which one is not possible. The soil nail, so basically what is in situ reinforcing, in situ, go to the site and then do it. So reinforcing soil while they excavated from top down. Okay, this mass is reinforced soil function to retain to less stable material behind it. The right soil condition, soil layering is rapid, is a very quick and economical means. In many applications, soil layering can at least disruptive way to construct a retaining wall. And the soil layering requires unusual amount of handwork, craftsmen, and usual work of geotechnical knowledge to construct. So here, how it looks like, the main typical section of soil nail. So earlier, this is a center. At the center, you see there's a drill hole first, and then insert this the nail, okay, and then inject the grout. This is similar type as I mentioned. So it's inject the grout material, and there is a centralizer. Centralizer is basically that the nail will be at the center, so that when grout materials, all the nail will be covered inside the grout, and then there is, as I mentioned, steel bar, centralizer, grout, drill hole, and then on the top you see over here the bearing plate, and then bearing nut and bevel washer, and then also there is a headed star. Okay, headed star. So these are the few exact, almost similar. Earlier it was like a anchor. It was a fixed length and free length. Fixed length was a thicker than more grout and thin. So it is here. It is uniform. That is the difference. There are different types of nails that are available. So one is the driven nails, one is the grouted nails, one is the corrosion protected nails, one is the jet grouted nails, and lounge nail. There are different types of nails. There are different specifications. What should be the diameter? What should be the strength of that? Most of the time, depending on the requirements, the company they will provide all the provide you all the data. How much is the tensile strength of the steel nail? How much will be the diameter? There are standard size of diameter is available. So driven nail is generally small nails, diameter 15 to 46 millimeter, limited length, so it's 20-meter length, made from mild steel that are closely spaced. Sometimes if you have a smaller length, so you can just weld it, or there is a spacer, you can attach it and then extend. Grouted nail, it is the bar diameter ranging from 15 to 46, again, stronger than driven nails. That strength is about 60 ksi. And grouted nails are inserted in the borehole of 15 to 10 to 15 centimeter, then cement grouted. Okay. And the reaped bar are generally used to increase the adhesion. So basically, instead of, just like a torch steel, instead of mild steel, it's more reaped bar. Then the corrosion protected nails. So obviously, this is for aggressive soil, permanent structures. You can use that corrosion protected nails. Jet grouted nail is a composite grout, soil and central steel rod up to 40-meter thick. So again, the jet grouted nail. Lounge nails between 25 to 30, this is smaller one diameter, and then 6-meter long, are fired directly into the soil. This is with a compressed air launcher. So it's just boom, boom, just launch it and then stabilize the mostly it is used for the slope stabilization technique. Okay. So these are the different properties of the nail. So the steel reinforcing bar used for the soil nail, commonly threaded, and maybe either solid and hollow. Most of the time is solid. Bars are generally nominal strength of 425 megapascal to 522 megapascal. Commonly in US, soil nails are used for solid bar, as I mentioned. So with tensile strength of 665 megapascal, and it can go up to 1035 megapascal. Threaded bar, typically nail available different diameters and length approximate 18 meter. Bars also having a diameter smaller than 25 should not be used, if it's just too small. And as I mentioned, so you needed a coupler to extend the length of this if it is more than 18 meter. So you need to have a coupler, and then you can use that, increase the length. Nail head, these are the different properties. I also need to check. Two main component is a bearing plate, and then hex nut and the washer and the headed star. It's almost similar like a ground anchor. Bearing plate should be made with a steel and then typically square, and the grade of the steel should be 250 MPa. And purpose of the bearing plate to distribute the force at the nail end to the temporary socket and facing wall. So that's the idea of using this plate. Beveled washer then placed, and the nail bar is secured to the hex nut. The washer nut should be grade consistent with that of the nail bar community. So again, strength is almost that same range. And head stud connection may consist of 4 head stud and welded near the 4 corner of the bearing plate to provide anchorage of the soil nail head for the permanent facing. So basically, after nail is done, and then put a steel mesh, and then put the shotcrete basically. Centralizer, how it looks like, is a PVC, made of PVC. So centralizer is a steel bar and then PVC, so that the bar will be at the center of the hole. Okay. There should be a regular interval. Typically, it should not exceed 2.8 meter. So it should be, every 2.5 meter, you need to have a centralizer. And along the length of the nail and distance about 0.5 meter from each end of the nail. Okay. This is how you do the centralizer. The grout, inject the grout, right? So you can inject the neat cement grout, basically is only the cement and water. And then it can be used for type 1, type 2, type 3, different type of cement can be used. And the water to cement ratio, it can be 0.4 to 0.5. Okay, in some cases, stiffer grout with a slump of order of 30 millimeter can be used. So these are occasionally the stiff consistent. Sometimes, because a lot of centralizer, if the grout material is very stiff, so then that may cause difficulty and installation of the centralizer. It will be difficult. So then ultimate bond strength. The characteristics of grout have strong influence on the ultimate bond strength of the grout interface. We just check the strength after 28 days. It should be 221 megapascal or 3000 psi. Typically, improved workability of the grout due to plasticizer can be extended for 1 hour. So basically, this is a cement grout, right? Cement is initial setting time is 30 minutes. So sometimes we add some stabilizer so that it delays the setting time. Okay. So, and then how it looks like, the grout pipe is typically heavy duty plastic tubing, varies from 9.5 to 19 millimeter outside diameter. And grout injected smooth and continuously, and between the space of the drill hole and the nail bar, filled with completely with no void space. And then when the grouting is done, so finally you see over here, there is a, using the streamy pipe. So obviously you need to do that. And so basically the grout injection is the streamy method, the grout pipe, which is previously inserted at the bottom of the drill hole until the grout is completely filled. Okay. Then this is how it looks like, the nail bar. Okay, this is high density polyethylene cover. Sometimes you just put it, the nail bar, you just put a cover of high density polyethylene material so that it protects from the corrosion. This is how we do the construction basically. Step 1, excavate a small cut, then make a hole using the drilling rig, and then third, installation of the nail. First, you insert the nail and fill it with grout. When the grout is done, then you put the bearing plate on the top, and then the shotcrete on the top, basically. Okay. So then repeat the same process. As I mentioned, just 1, 2, 3, 4, 5. So it is from the top down. So 1, 2, 3, 4. This is 4 nails over here. And then you have a plate on the top. You see here, plate on the top and nuts, over there. And then there is a drainage layer. Also, there should be a shotcrete on the top. Then this is the final facing or permanent wall, how it looks like. Okay. This is just most of the time when you design any soil nail, so you need to go to the site and see the plan, how many nails you need to stabilize the slope. This is a project I was involved here in Illinois. We have a national forest, Shawnee National Forest, to how to stabilize the rock fall. Basically, this is the plan used, and these are the different nail size, proposed nail size. And this is how it looks like, actual side is quite a steep slope. And so basically, these are the different points over here, that inject this, the grout. So how it looks like, I mean, this is closer view of soil nail inspection later on, and then also that nail insertion into the ground slope ground, basically. This is how it looks like, the soil nails, and this is centralizer. You see the centralizer over here, so that it can be at the center, closer view. Then this is how they do. Basically, they use a mixture in agitator in that grouting method we already explained. The same thing over, you can see it over here. So basically, you're using ordinary Portland cement in this project. So, and then they use this, if there is in a cement, there is a lump or anything, that can be, discarded. And then mix it over there, and then they pump it to the nail. And then this is the test of nails after the installation. So this is how they test the nail, the load test after 7 days or 5 days. And then, so basically that's how we have seen that actual project, how the nail is installed and stuff. Advantages of soil nail is with the right soil and site condition, rapid and economical means of construction are retaining support structure, retaining wall, shorter drill hole, smaller diameter bar for short length, retaining wall are secured laterally into the soil, eliminated piles and foundation footers. Grouting only once is required, saving time and labor, and its technique is flexible and easily modified. Creates less noise and traffic obstruction, less impact on the nearby properties, allowable in situ strengthening of existing slopes with the minimum excavation, allow excellent working space in front of the excavation face, can be used for the strengthening either natural slope, natural or man-made cut slope. So you can use for anything. Obviously, every method has some advantage and disadvantages. These are the disadvantages. So nail encroachment to the retaining ground, rendering unusable underground surface. So we cannot use the nail is there. So same thing for ground anchor also. We cannot use the underground space. Generally, larger lateral strain during removal of the lateral support or ground surface cracking may appear. Tendency of high ground soil due to drilling technique, particularly for the coarse grain soil, less suitable for the coarse grain soil or soft clay soil, and suitable for excavation above the ground water. The water table is there, so then it's not good. This is how using the rotary drilling method. So how we're drilling it, and then insert the nail, and then the grout it. Temporary wall facing construction. So again, temporary wall facing soil nail application usually for constructed using shotcrete. As I mentioned, it's just like a cement and sand, only cement and sand slurry. And thickness of the temporary shotcrete facing wall is between 75 to 10 millimeter, 100 millimeters, so 3 to 4 inches. Shotcrete provides the continuous support of the layer over the excavated face and can also serve fill voids and gaps using different fiber or geotextiles reinforcement. So how it looks like? So it looks like here, like the nails, you cannot see the nails. So nails are there, several nails, and then you put a steel mesh and then put a shotcrete using this with high pressure cement and sand, basically. Type of shotcrete method using dry method or wet method. So dry method aggregates and sand aggregates, less percentage of aggregates. Cements are blended dry fed to the shotcrete ground, depending on the features. So we can use that to most significantly determine shotcrete quality and durability of the cement. So we need to check that. And for a high cement factor, usually 350 to 400 kg per cement per meter cube is generally used. So more cement is generally used for the durability. Then steel bar reinforced was added to the shotcrete as a part of wet mix, increased ductility, toughness, and impact resistance. And fiber tends to reduce the shotcrete brittleness. We use some fiber also and then increase the compressive and the flexible strength. So wet mix, again, wet mix yields fresh concrete typically 6 to 8 meter cube per hour versus 4 to 6 meter cube hour for dry mix. So it's much it will generate more concrete in wet methods. And so equipment is readily available because the shortcut ground and moisturizer are not needed in the dry mix. So these are some of the application of the dry, whether you should dry or wet. Supply of ready mix concrete from the commercial batch plant is readily available for convenience. So this wet mix is readily available. Principles of nail. So we need to check that the potential failure modes. So earlier one you have seen that a nail may fails different. It may fail external failure. It may fail internal failure. It may fail compound failure. So same thing like a retaining wall or MAC design walls. You need to find out the factor of safety for different things, external stability or internal stability. So here, failure mode, how it looks like. The first one is the soil nail pull-out failure. This is the pull-out failure. So this is the idea is you need to steel reinforcement. This is that transfer the tensile strength load into this soil over here because because the pull-out it just the soil nail pull-out failure. This is pull-out failure. Bearing capacity bar grout pull-out failure. So this is there is not enough bond between the grout and the nail bar. So then the bar may come out. Okay. So that is also bar grout pull-out failure. Then this is the worst case, like a nail tensile failure. So if the nail fell itself, so that is the worst. And then the nail bending or the shear failure. If this is a situation also like that, so then that is not good. So this is like a internal failure of the system, internal. So nail itself, nail bond, and then also nail failure pull out. So few things you need to check. Now this is external failure. External failure is because of the global stability, the shear failure, or the sliding failure, or the bearing failure. So same thing like a retaining wall. You studied like a external stability. You need to do that overturning failure, whole thing may retaining wall may overturn, it may slide, or it may just hold bearing capacity failure any direction. So same thing over here also external failure. So you need to check internal failure with the external failure. So now the facing failure may occur, the facing wall, and then also you see the facing flexural failure is facing puncture shear failure. It may facing like a headed start failure. It may also the start where we attach this start, it may fail also. Then this is like the failure potential failure surface during construction. So what is happening? As I mentioned, this is top-down approach. Excavation 1, phase 2, like that, and then what is going to happen? The deflection you need to check. You need to see the tensile strength of the nail. And these are the critical failure surface for the different phases of construction. So phase 1, phase 2, what is happening? How much is the tensile strength? Maximum it can take. So all these things you need to calculate while designing. So basically you need to see this load transfer mechanism. Over here, again, this is imaginary failure line. Over here, this is the imaginary failure line. This is the nail, and you see the imaginary failure line. This portion is like on this tensile on this side. This portion is friction is trying to, hold this. And then distribution of the tensile strain along the nail, it looks like this, okay? And this is the active zone over here. This is the passive resistance zone and active zone, okay? And this is the facing wall. So what is happening? The stress transfer mechanism, it looks like this. How much is the nail force? T maximum you need to calculate. You need to find out how much is the T naught. The tensile force of the nail head also you need to calculate. And the facing. DH is the diameter of the drill hole, and L is the length of the soil nail. So basically, again, maximum tensile force and a critical failure surface. Again, this will give you a guideline. So for any soil nail design, 3-4 things you need to check. So first thing is, what should be the length of this soil nail? What should be the diameter of the soil nail? What should be the spacing of this soil nail? Vertical spacing. So not only the vertical spacing, what should be the horizontal spacing of the soil nail? So 3-4 things you need to check. Okay. So these you give a guideline. So just for example, this is the height of the retaining wall is h. So this is approximately 0.3 to 0.4 times h. This is like a locus of the maximum nail force. Again, these are imaginary lines, right? So this is, again, this is a critical failure surface. It's the dotted line over here. And then how the tensile distribution of the tensile force along the nail is going to occur. So this is, and then also how much is the length of this length, okay? So beyond, so we need to find out the critical failure line, how much is that? Beyond this failure line, how much is, the active zone, basically. You need to calculate that and then find out how much is the total length. Same thing, or if you are designing MSE wall design, how much is the active zone, how much is the passive zone, easily you can calculate the total length using that. So this is very important. How the distribution, earth pressure distribution over here. For MSE wall, it is like this. When doing MSE wall lateral pressures, you see the top surface, there is no pressure, and it's go down, pressure is increasing, right? So gamma times H times K. So K is the active earth pressure, or Ka is the active, Kp is passive, or K naught is the earth pressure at rest. So, but here in the soil nail, you see the pressure on the top is more, and then it's go down. Same thing for back wall. Back wall also. Here it is initially it is low, and then it is almost constant. Okay? So that is the difference between the lateral load distribution is, and this is very important to design for where is designing MSE wall design or soil nail or tieback wall. Soil nail, what are the design consideration we need to use? There are several methods of soil nail designs. Methods are used. I just added all these different methods. There is the German method, this bilinear slip surface they used. Parabolic method, so is it a Davis method, French method, circular, or any shape? So again, depending on how the failure plane is going to be, like a slope stability analysis, sometimes you use the circular failure. That can be planar, it can be anything complex. So depending on that. And the kinematic method, they use log spiral methods. Caltrans, California Department of Transportation, they use the bilinear method. Boulder Associates company, they use circular failure method. So these are the different assumptions they made, and they come up with the different design methods. And there are different softwares also available to design soil nail. There is a software called Snail. So you design the soil nail using Snail. There are several types, several softwares are available also. So typical design parameters. So if you want to design, again, whatever the method you use, you need to first you have to assume something, and then use that. Then you check, okay, whether the tensile strength is okay, whether its bond length is okay, whether the length is okay, whether the diameter is okay. So all these things you need to check, and finally you need to decide. Okay. So these are the typical design parameters. So each nail has an influence area is less than 4 meters square. Again, minimum soil spacing should be at least 1 meter. Minimum length of nail should be 0.8 times the height of the wall. Drill hole diameter of the grouted nail, it should be 100 to 200 millimeter. And then also that the minimum nail inclination should be 15 degree, 15 degree nail inclination. Ground anchor is different. Ground anchor, it can be horizontal, it can be vertical, it can be inclined. But here, most of the time, the soil nail is inclined. Okay. External stability and external stability, we just mentioned. External stability itself, the nail, inside the nail felt, and the bond between the grout and nail, all this stuff we already explained. So we need to check the external stability and external stability, internal stability, and find out how much will be the factor of safety for the temporary structure and for the permanent structures. So obviously the permanent structure, the factor of safety is more compared to the temporary structures. In some cases, it may be less. But internal stability, you see the nail pull-out, nail tensile failures. This is the most important. You can find out from here how much will be the factor of safety. This is the recommended minimum factor of safety is required if you are designing this. So then distribution of the tensile strength. Tensile force, how it looks like. So here, nail tensile capacity, facing capacity, pull-out capacity. So we need to check which one is important and which one should be more for the safe design. So, you need to check the facing capacity. Sometimes it should be the pull-out capacity. It should be more than nail tensile capacity. It should be more than pull-out capacity. So all these things you need to check. So which one is more that controls, basically, whether it is pull-out controls or tensile failure controls or facing failure controls. So we need to check that using this basically tensile force distribution. Then also the maximum tensile force is, you can find out using this equation, the normalized nail load, Tmax divided by K times gamma times H. How much is the height of that retaining wall times horizontal spacing times vertical spacing. And you see, with depth, so after certain depth, so it was uniform, and then after certain depth, is going down. Okay, normalized nail load can be go down. Then the front pull-out capacity, you can find out using this equation. If you know the connection strength between the nail and the facing wall, so you can find out the pull-out capacity. Rear pull-out capacity also you can find out if it is connected to the bond length. And then just like this one pull-out capacity is basically the one we already discussed, that for the ground anchor. See how the nail is anchored into the soil. Okay, so you need to know how much is that ultimate bond strength, how much is the diameter of the hole, how much is the nail length in the passive zone. So the first one is the active zone, failure line. Below the initial portion is the active, and then beyond this failure line is the passive. So we can calculate using this equation the front pull-out capacity, the rear pull-out capacity. This is again for the internal stability. And then the bond length you can find out from this table. Okay, ultimate bond length for the rock, for the cohesionless soil, that is granular type of soil, sandy type soil. For fine-grained soil, basically silt and clay. So you can find out again what construction method you are using, rotary drilling method or driven casing method, auger method. So different type of drilling method, different type of soil and rock, what should be the bond length? So that is given. Easily you can use this and calculate your in your design for ultimate bond strength. And design chart for soil nail force and nails. There are different design charts are available. So you can use that chart to design your soil nail. Again, for any design, you need to find out how much is the length of this nail, diameter of the nail, and that is the two main things: diameter of the length and nail, and length of the nail. Okay. So homogeneous ground conditions. So there are different conditions. People did like a 15-degree angle. Global factor of safety is 1.5 times minimum nail length. Factor of safety, again, for the global factor of safety, 1 for maximum size design nail force. Nail diameter should be 100 and normalized cohesion should be 0.04. So you can find out from here normalized cohesion. And you can find out the normalized pull-out resistance also. Pull-out resistance, this is normalized cohesion. And this is normalized pull-out resistance. You can use this equation. You know the ultimate bond strength. If you know the spacing, you know the vertical spacing, you know the factor of safety per pull-out, then you can find out the ultimate bond strength. And then if you know this, then you can find out how much is the maximum design nail force. So if you know the design nail force, then you can find out the normalized maximum design nail force determined from the design chart. So you can find out from there. So this is the design chart that are available. You see there are 4 cases. One is height of the retaining wall is straight, and there is backfill slope is also, there is no slope. So this is the design chart you can use. You can find out the normalized nail force. You can find out the normalized bond strength depending on the angle of internal friction of the material. Then you can use like you see the wall is vertical, but the backfill is 10-degree back slope. So you can use this chart again, normalized design chart force, normalized nail force, and normalized bond stress. You can use this chart. Then the third one is wall itself battered 10-degree, and the but backfill is back slope is the 0-degree angle with the horizontal. Then you can use this chart to find out the bond strength and normalized design force. And then the last one is like a 10-degree angle, and then also back slope is 10-degree angle. So you can find out that. So if you know this normalized design load force, Tmax, if you know this normalized bond strength, so what you can do, you need to do the correction factor for the soil nail force. So H by L by H corrected is equal to C1L, C2L. So this is the length correction factor for the drill hole diameter. C2L is the length correction for cohesion, length correction factor for global factor of safety, and CF1, the last one, the Tmax, corrected value is using this equation. Is this one you get from the chart? You need to do the correction, and the correction factor you can get from the drill hole diameter and also for soil cohesion. So there is a chart also here to find out C1F and C2F over here, C1F and C1L, and correction factor of C1L and C1F. So all these different factors over here. So you can calculate. So basically you can calculate H by L corrected, T by X corrected. So if you know from this chart, and you can finally, and then there is an equation for also C2L, C2F, and C3L. So over here, C2L and C3L and C3F. So this is the one you can use this equation, and this is the normalized equation. And finally, from here, you can find out the required cross-section area of the nail bar. So you see here Tmax S and factor of safety for the nail tensile strength or rupture, and the yield stress of the nail. You can find out that the nail bar area. If you know the area of the nail bar, you can find out the diameter of the nail bar easily. So this is the threaded bar properties, the nominal bar designation, and the cross-sectional area, and then ASTM grade, yield strength, all these things are given. So you have an idea. And finally, you can find out for maximum facing tensile force. You can find out over here from how much is the maximum design tensile nail force and how much is the S maximum. So S maximum is the maximum nailing space. So you need to check the vertical spacing or horizontal spacing, which one is the maximum. You need to take that one. Okay. Sometimes in design, sometimes you use horizontal spacing and vertical spacing are equal. But here in this case, you need to take that S maximum. So to find out how much is the maximum tensile force. Then again, internal sliding analysis you can do. So basically, I need to calculate how much is the factor of safety. Just for example, over here, the height of the retaining wall is a slope backfill, and the nail is there. So this is imaginary planar failure surface, and the phi is given. And then what are the forces is acting? And then what are the force, the vertical load, or the normal load, shear force, everything you can calculate. Again, you can calculate the factor of safety using this equation. Factor of safety is how much is the resisting force, how much is the driving force. So that's what you can calculate, and you'll get that. So basically, ultimately, you can find out even the external analysis, you can find out the internal analysis. Again, same thing, same way you can find out the retaining wall design. So you can do that exactly same way. So how much is that for, this is for the weight of that. And then also how much is the lateral pressure will be acting, why will be acting, that will be, if you take a moment at the toe over here, and then find out the factor of safety. So factor of safety, again, same thing, it can be factor of safety against sliding. So you can use this equation for factor of safety against sliding. And then you can calculate also for the deformation of the soil nail. So that also in the soil wall, you see that initially it was like this. Now it is how much is the deformation. So you can calculate of the soil nail deformation walls. And also there is a limit for that. How much is the deformation? There is equation for that. You can calculate from there deformation of the soil nail, how much is applicable in that deformation. So, and then how much is the C value should be for the different type of soil. So this is the equation is given, so we can easily calculate how much is the deformation. So this is what I'm talking about, the deformation of the soil nail wall. Okay. And then finally, typical drainage and retaining wall. So you have to have the drainage over here. And then is the retaining soil nail. And there is a drainage. Obviously, there is a weak fall should be there. So that same thing, same concept is basically it should not, the water should not keep more pressure on this wall. Okay. So basically, as I mentioned, for the soil nail design, there are several design chart. There are factor of safety you need to calculate. These are the different charts you need to use. Correction you need to use for that, and then for different, if it is like a 10-degree batter, 10-degree back slope, so easily you can use this chart to calculate the normalized bond strength, normalized maximum design force you can calculate, and then do the corrections. You do the corrections, and then so basically it is a corrected length over here. L by H corrected is equal to, if you get all this value from here, you will get some value. So from there, if you know the height of the wall, then you can find out L. So if you can calculate the length of the wall easily. So same thing also here for the T max, how much is the tensile strength and stuff, the corrected, easily you can find out. And then later on, you can find out the diameter of this from here. If you know the tensile strength maximum, you can find out the diameter of this, of the soil nail. All right. And then there are a lot of design charts that are available. You can use that. So basically, L by H ratio, if I know the tensile strength of the steel, easily there is a standard, the German method, as I mentioned. So there is a given values that there are different ratios. So easily you can find out what is your soil type, and you can easily find out what should be the length of this, what should be the diameter of this soil length. So very easy. Or otherwise, you can use the software, Snail or any other softwares. All right. I just went so quickly. Can I stop here now for a minute?
Yeah, thank you, sir.
Yeah, I mean, this is just
Continuously talking from more than 2 hours.
Yeah, I mean, there's so many things you need to cover, but that's the syllabus, because we are not going to go in detail. So I'm just giving basically the overview of stuff, If you want to do design anything, so you need to, solve some problem using, all this equation and stuff, then only you'll know. But I mean, I'm just explaining the whole process, So now I have to complete another 2 topics. One is organic soil or peat soil stabilizations, and then also MSC wall design. So how much time I have? Like, can I even break or just I continue?
As per your comfort, sir.
So that I'll finish quickly, maybe in 1 hour.
Okay.
So let's start now. Otherwise, it's 9 o'clock there, correct?
Okay, sir.
Yeah. So let's start then. Or if you want break like 2-3 minutes, I can.
Sir, no problem.
Okay. Yeah, I'm not taking any break. If someone wants to take, just I'm just going to
Okay,
share
okay.
this
You can
now.
continue then.
Okay.